Hello and welcome to all. Today we will discuss about uniform circular motion. First of all, we have to understand what is the circular motion. Here is the diagram. In this diagram, an object or a point particle is presented at initially at point A. After some time, it changes its position at point B. Here, the angular position of particle at point A is theta 1. After time t, the angular position changes from theta 1 to theta 2 at point B. Then we can say that if an object changes its angular position with time, then we have to say that the object is in circular motion. And the term uniform represent that the speed of the particle during circular motion is constant. Then the motion of the particle is known as uniform circular motion. In the uniform circular motion, the speed is constant throughout the motion, but the direction of motion is always changes. But the direction of motion is always changes. We can understand by this diagram. This is the particle at point A. After some time, it changes its position at point B. After some time, it changes its position C. Then at point A, the representation of velocity is like that VA. At point B, the direction of velocity represented like that VB, and at point B and at point C it is represented like that. That is, the velocity at any point of a circular path represented by draw a tangent at that point. As we have seen that the direction of velocity is continuously changes with time, then we have said that in uniform circular motion speed is constant, but velocity is not constant. It changes continuously with time, because velocity is a vector quantity and it's depend on the uh, direction of the motion of the particle, which is continuously changing on the circular path. As we know that acceleration is change in velocity with respect to time. With respect to time, here velocity is continuously changes, then acceleration is present in uniform circular motion, and the magnitude of acceleration is represented by v square upon r. Here v is linear velocity of the particle and r is a radius of circular path. This acceleration is known as centripetal acceleration, which is acted in radially inward direction, or we can say that acted always towards the center. The centripetal acceleration acted always in radially inward or towards the center. In the above diagram, the 3 points which I have located in the previous diagram, in this diagram, uh, I am trying to show the direction of centripetal acceleration on these diagrams. The magnitude of centripetal acceleration at all the three given location is constant, which is v square by r, but the direction of acceleration at all the points in radially inward direction or towards the center, as we have seen this diagram. From the definition of force, we know that if an acceleration is present at any condition, then there will be always a possibility of presence of force. In this condition, here a centripetal force is always acted towards the center, which is represented by, as we know that F will be equal to mass into acceleration. Mass, it is the mass of the particle which is in circular motion, and acceleration, it is the centripetal acceleration, which is v square by r. This is the relation for centripetal force, which is mv square by r, and it always acted towards the center, that is radially inward direction. Now we can say that in uniform circular motion, only speed is constant and the magnitude of velocity is constant, but direction of velocity is continuously changes. Then the velocity, therefore acceleration and force is not constant, because these three are vector quantity. It depend on direction of the motion of the object. For circular motion, centripetal force will always be equal to the net force acted towards the center. Here is some examples related to the uniform circular motions. First one is motion of Earth around the Sun. This is the diagram in which the uh, point E represent the location of Earth in its orbit, and at the center Sun is present. Between Sun and Earth there is always acted a gravitational force between these two bodies. Sun attract Earth towards itself with the force, gravitational force, which is represented here as Fg, due to which it follows a circular path around the Sun. Here the Fg or gravitational force is the required centripetal force. Centripetal force in any celestial bodies, we can say that in in the same manner in which Earth is revolved around the sun, the moon is also revolved around the Earth in the same manner. Here is the next example in which the motion of electron around nucleus in an atom. This is the diagram. This represents the location of electron, and this circle represents the path of motion of electron in a circular path. As we know that electron and proton always attracted each other. At center or nucleus, proton and neutron are present. Proton always applied a attractive force on electron, which is represented by electrostatic force. Here if we represent the electrostatic force, and this electrostatic force provide the required centripetal force. Here the electrostatic force Fe is the centripetal force which causes centripetal acceleration, which will be equal to mv square by r. Here v represent the velocity of electron and r is the radius of the orbit of the moving electron. In next lecture we will discuss about term centrifugal force and its importance. Thank you.